Welcome back. This is Networking Part 4. Today we're going to be talking about NAT, DHCP, and routing. Okay, so we'll discuss the importance of all of these different things, DHCP, NAT, we'll go over different routing schemes, and then we'll talk a little bit about Wi-Fi security. So DHCP, this is something very important. When we connect our phone or computer to a new network or a Wi-Fi network for the first time, what's going on in the background? So DHCP, which is short for Dynamic Host Configuration Protocol, what this does is before the phone or computer can connect to the internet, we need to get an IP address on the network. So how do we get this IP address? We need to ask the DHCP server on the network for an IP address. A lot of the times this is built into our router. So our routers have a DHCP service running on it. So what we do is our phone or our computer says, hey, I need an IP address, where's the DHCP server? And then our router or the DHCP server will say, here I am, and here's the IP address there. So in larger environments, we have dedicated DHCP servers. At home, like we talked about, this is built into the router generally. So in an enterprise, we can say, I need an IP address, where's the DHCP server? And then the DHCP server will say, here's your IP address, and we are assigned that IP address. Now this IP address is not permanent. This is a leased, which we'll talk about in just a second here. So here's a little overview of what's going on with the DHCP request. So the client, or the DHCP client, is going to try to discover where the DHCP server is. So it's going to send out a broadcast message, kind of like ARP, and then the DHCP server will reply back to the client and say, okay, here I am, here's your IP address, do you accept? The client then says, okay, I'm going to accept that IP address. The DHCP server then acknowledges that, and the IP address is assigned. So we talked about this a little bit. The client discovers the DHCP server by sending out the broadcast packet onto the network, asking where the DHCP server is. The DHCP server then offers the client an IP address, and then the client accepts the request and claims the IP address. The DHCP server then acknowledges the client accepted the IP address. One thing to keep in mind, I think I talked about this just a second ago, is that the DHCP lease, it's a temporary assignment for an IP address. So when we get an IP address on a network, this is a temporary IP address. We're borrowing the IP address from the DHCP server. Sometimes the lease is set to 1 hour or 2 hours or 8 hours, and after the lease period, the client must either renew that IP address or get a new IP address. The reason this happens is because it helps to free up IP addresses on the network. If these IP addresses are never released back into the network, every time you connect a new device, that IP address would never be usable again. Okay, now let's talk about something called NAT, which is short for Network Address Translation. So after our device gets a private IP address from the DHCP server, we still need a way to connect to the wide area network, or the internet. So here in this picture, our phone is connected to the internal network, to our router. All right, we got an IP address with DHCP, and then the router is going to help us connect to the public network. Now, NAT is kind of a complicated topic to understand, so I'm going to go kind of slow on this topic. If you understand NAT, feel free to fast forward through this part. Okay, so network address translation is a way to map private IP addresses. Right, we talked about how private IP addresses start with 192 or 10.0 or 172.16 generally. So a public IP address is necessary to serve, so servers on the internet can respond to our requests. So internal IP addresses can only be used internally on an internal network like your home network or your work network. Public IP addresses can only talk to public IP addresses. So how do we bridge the gap there? We use something called NAT. Generally, NAT is going to happen on your router. If you have a Wi-Fi router, it's going to happen on that router there. So routers are serving multiple purposes here. They route traffic from one network to another network, and it also takes care of network address translation. So we can map an internal IP address to an external IP address. So a NAT table is how the router keeps track of this. So our router keeps track of all these mappings in a table. And like I talked about, the public IP addresses can only talk to public IP addresses, and private IP addresses can only talk to private IP addresses. So we can map one to the other so private addresses can reach public resources. Without NAT, we wouldn't be able to do this. So here's an example table. We'll go into more examples so this makes more sense. But we have a private IP address of 192.168.1.7. And remember, we have to open up a dynamic port so we can request or listen for a response from the server. And let's say we're trying to reach Google. So the router is going to create something in its NAT table, an entry. Say, here's your private IP address, but the router has its own public IP address, so it's going to map it to its IP address and a random port on the router. So to demonstrate this a little bit more, let's give an example. So let's pretend that we want to connect to Google on port 443. Right, that's just the secure version of a website, or HTTPS. So Google's IP address is 88.88.88.88 on port 443. This is an imaginary IP address, of course. Now let's say our router's public IP address is 22.22.22.22, just so we can illustrate this example a little easier. And keep in mind, a router has two IP addresses generally. So in this case, we have an internal IP address and we have an external IP address. Remember, routers need to bridge two networks together, and so they're required to have two different IP addresses so they can bridge different networks together. So our router's private IP address, we'll give it 192.168.1.1. And then our private IP address is going to be 192.168.1.77. Okay, and now this is where it's going to get a little bit tricky. So make sure to pay attention here. So our computer is going to be sending a request to Google. So we start with a packet from our computer, and the packet is going to say, this is where I want the packet sent. 88.88.88.88 on port 443. And we put the source, which is our computer, .77. And we open up a random dynamic port. It can be any port, but in this case, we're going to use 49300. Not super important, but we need to open up a dynamic port so we can get a response. Right? Data can only be transferred to open ports. So if we don't have a port open, we can't receive any data. So after we create this packet is forwarded to the router. Now the local area network address, remember we are on .77. Now what the router does is it's going to say, okay, I'm going to make an entry in the NAT table. So I'm going to map your port and your IP address to a random port I'm going to open up on my public IP address. So in this case, the router is going to open up a port 1234 for this NAT entry. And then it's going to actually send this packet to Google. So with the destination now, it's going to change the destination packet to be the actual router. So when Google gets the packet, it reaches the destination packet, but the source on the packet is now changed to the public address of the router. So when Google says, okay, you want the cat picture, I'm going to send it back to you. It's going to send it back to the public IP address of the router. So the router gets it, and because it receives this picture or the packet, there's a NAT entry in the NAT table. So now it can forward this packet to the IP address and port number internally. So it's kind of a man in the middle, a middleman essentially to forward stuff back and forth, or a proxy essentially. So the client says, I want to send data. Hey, can you send this for me, router? The router says, okay, I'm going to keep an entry here, and then sends it off to Google. Google says, oh, the router's the one that sent it to me, so I'm going to send it to the router. And then the router looks it up in the NAT table and says, oh, this is a response for .77, and it'll send it back to us. So this concept can get a little bit complicated, so if you need some more information, I can leave a link in the comments about natting. Now let's talk about routing. So routing is how data is transferred over a network. Routing makes sure traffic is sent in the most efficient way possible, and there are different ways to measure this. Now we can get into math and networking and science. This can get very, very complicated, but we're going to keep it very high level for this. Most people don't need to know any more than what we're going to be covering here today. So routing, there are two different ways to route. We can do static or dynamic. Static routing is where generally a system administrator creates a routing path that is manually set. So all routes have to follow this predefined path that's set by the network administrator. These are generally on smaller networks or on enterprise networks. So if you're at a university, sometimes the network administrator might say, if you want to send data to the internet, you have to go through building A's router to building B's router, and so on and so on. But if you're in building D, you might have to go through different buildings as well. So they're predefined routes. And then dynamic routing is where the routers actually decide the best way to send it. So with dynamic routing, there are different ways to determine what the best way is. So if we want to do a distance-based routing, this will take the shortest path to the destination. So RIP, Routing Information Protocol, is one of those protocols. And then IGRIP, EIGRP, so Enhanced Interior Gateway Routing Protocol. These are two distance-based routing protocols. And then we have speed-based routing. So OSPF is going to open the shortest path first, or that's what it stands for, Open Shortest Path First. There are several ways it determines this. We're not going to get into details. But if we look at this example here, and we start here, if we're going by speed, we would actually go through this top route here. So 3 plus 1 plus 2 plus 1, right, is going to be shorter than, or is going to be faster than the shorter route. But the shorter route might actually take a little bit longer. So 5 plus 8 plus 1 milliseconds would actually be longer in this instance. So depending on what protocol we're using, the routes would be different. Now let's briefly touch on wireless networks here. So Wi-Fi is a way of sending data via radio waves. Our cell phones can use Wi-Fi when we're connected to a wireless access point. Our laptops generally can do that. And we use something called the 802.11 standard. So a basic service set identifier, or a BSSID, this is a unique way of identifying a network. So here's an example of one. Now when we connect to a Wi-Fi, we generally don't say, I want to connect to 00-B4-B51-5110D7. We connect to things that have nice names that we can remember. So since we don't remember BSSIDs very well, our wireless access point allows us to actually add like an alias or something. This is called an SSID, which is an easier way for humans to identify a network. So we could actually choose different Wi-Fi networks that are available to us. So these wireless access points are broadcasting, these SSIDs constantly. And there are different ways to turn this off. So if you didn't want to broadcast your SSID, you could turn that off in the router settings. Now, different types of wireless security. We have WEP, which is Wired Equivalence Privacy. It's a very old way of securing Wi-Fi. Do not use this. It can be cracked in seconds to minutes. And then we have, WPA, Wi-Fi Protected Access. So this was a temporary fix for WEP, more just to kind of wait until WPA2 came out. So WPA2 is a secure, and it's pretty much what we all use today. It's what we use to encrypt Wi-Fi networks. I think WPA3 is kind of out already, but a lot of routers don't support it, or a lot of devices aren't supporting it yet. So for now, WPA2 at the time of this video recording is the standard for Wi-Fi. So if you're connecting to a network that is using WPA or WEP, consider upgrading to WPA2. All right, so today we talked about DHCP, NAT, basics of routing, and a little bit on Wi-Fi security here. So hope you're enjoying this. We'll talk more about networking in the next video. Stay tuned, and hope you enjoyed. Bye.